Hi students, today we are going to discuss the very important law in thermodynamics, which is named as the first law of thermodynamics. Now before getting into the statement, let us take the example first. So here is a cylindrical container. So the block diagram of a cylindrical container is drawn like this. The walls on all sides, the internal walls of the cylinder is insulator. So in thermodynamics, whenever you see these crossed lines, it means a insulator, thermal insulator. Heat cannot flow either into the system or out of the system. That means wall. But the bottom of the cylinder, you can see it is not crossed lines. It is a continuous line. That means it is a perfect thermal conductor. That means the heat can enter inside the system or leave the system through the base. So it is a cylindrical container whose walls are perfectly insulating. Only its bottom is conducting for the allowance of heat. And it is also provided with a piston. What type of a piston it is? It is a smooth, airtight and frictionless piston, which is provided with a handle. Okay. Now let us consider that some gas is taken inside the cylinder. Any gas can be taken. Ideal gas also can be considered. So initially some gas is taken inside the container, and this gas will have some initial pressure, volume and temperature. Like that, initially let us take the internal energy of the system is UI. So we have studied the internal energy of all the gas molecules is equal to the sum total of its kinetic energy and potential energy of the molecules. So the total internal energy of the system, here gas is the system taken inside the container. So what is the initial internal energy of the system I have taken? That is U initial, that is UI. Now I am going to supply some heat through the base. So you can see here these arrow marks. Now these indicate the quantity of heat supplied to the system. So Q joule of heat, you can keep a gas flame, a Bunsen burner below the base of the cylinder, and you can supply some quantity of heat to the gas, which is the system. Now immediately after this quantity of heat flows into the system, what changes may take place? The immediate change is the temperature of the system will increase. Is it not? Because heat is flowing from the source through the base and it is flowing into the system. So when heat flows into the system, the temperature of the gas will increase. As a result, what will happen? Its internal energy will increase. So initially its internal energy is UI. Now after supplying this heat, let us take its internal energy has increased to U final. So from U initial to U final, there is a change in the internal energy. In addition to that, what may anyone expect here? What will happen when air is heated in a closed test tube we have studied? It will expand. Like that here, what may happen to the gas also when you supply heat from outside? The gas may expand. So when a gas tries to expand, what will happen? It will try to exert some pressure on the piston. So it is exerting a pressure on the piston. So it is exerting a force first of all, okay? A force is exerted by the expanding gas in the upward direction. And if you divide this force by the area of cross section of the piston, let us take A is the area of cross section of the piston. So this force per unit area only is called the pressure exerted by the system. Because of this upward force or this pressure exerting in the upward direction, the piston will try to move in the upward direction. Understand? So this is the initial position of the piston and this is the final position of the piston. Final position of the piston. So that it is moved through a small distance dx, let us say. The piston is moving upward. So who is pushing the piston here? The gas is pushing the piston. So this only is called the work done by the system. So work done we have studied, it is force into distance or force into displacement. So here what force is exerted by the gas is F. Through how much distance is the piston moving is dx. So this F dx must be the small work done by the gas. So naturally the quantity of heat supplied, that is Q joule, has done two jobs. It has performed two jobs. What is the first job? It has increased the internal energy of the system. For that a few joule of heat must have been utilized. And naturally the remaining part of the heat must have been utilized for what job? For what purpose? To perform work. That is to push the piston upwards. So this total heat supplied must be equal to the sum of the two jobs performed by the gas. That means what? One is the change in the internal energy of the system and what is the second one? The work done by the system. This simple statement only is the first law of thermodynamics. I hope you must have understood what is happening to the quantity of heat supplied to the system. So what is the statement you read now? The amount of heat energy supplied to a system is equal to the sum of the change in internal energy du of the system and the work done W by the system. So I am going to rewrite the statement mathematically. So what is the quantity of heat supplied to the system? That is equal to Q and that is equal to the sum of what? The change in the internal energy. So that is du plus the work done by the system is W. Understand that? So this also can be written in another form. So this is also equal to what? Written in another form. Du is equal to Q minus W. Q minus W. Both are one and the same. Both are one and the same. In different textbooks, notations are different. But the meaning is one and the same. Understand? So this also is what? In other words, we can also write that is a change in the internal energy means what? U final minus U initial. This is equal to Q minus W. This is another format. But from all these three, what do we come to understand? The energy which is supplied to the system is equal to the sum of the other two forms of the same heat energy only. So naturally, this is based on the law of conservation of energy. Energy which is disappearing is converted into work. So energy which is absorbed by the system is equal to the energy released by the system. Naturally, the net energy, okay, the net energy is equal to 0. Okay, so I can say that it is based on, okay, this law is based on the law of conservation of energy. So law of conservation of energy. This is also very important in the statement. So in the examination, whenever the statement of the first law of thermodynamics is asked, you also must indicate that it is based on the law of conservation of energy. Understand? So now, the mathematical statement I have written du is equal to Q minus W. Okay, what is W here? Work done by the system. What work it is doing? It is pushing the piston upwards through a distance dx. So let us say the small work done, okay, the small work done. What do you mean by the small work done? When the displacement dx is very small, the work done also is very small. So the small work done by the gas is given by dW. So dW is equal to F into dx. F into dx. I told you that this force divided by area of the piston is equal to the pressure, is it not? Therefore, this also is equal to what? Pressure into area. Pressure into area. Force is also written as what? Pressure into area. Okay? Into dx. Or this can be written as pressure into, okay, pressure into A into dx. I am adjusting the terms. Now you can see that it is a cylindrical container. It is a cylindrical container. The piston is circular and its initial position is down and the next final position is up. So that if you find the change in volume, that is base area into dx. So this base area into dx must be the increase in volume, that is change in volume. So this is also equal to what? This is also equal to pressure P into change in volume dV. Understand that? So dW is now equal to P into dV. Therefore, the first law of thermodynamics can also be written in another form now. Another form, what is that? Therefore, the change in internal energy is now equal to, that is quantity of heat supplied minus P into dV. So, all these expressions are one and the same. That is the first law of thermodynamics. So clearly you must be thorough with the first law of thermodynamics. What is the statement? According to the first law of thermodynamics, the quantity of heat Q supplied to a system is equal to sum of the two terms. What are they? The sum of the change in internal energy of the system du and what? The work done by the system W. I hope you must have understood well. Fine.